In this video, I will talk about the prerequisites to calculus that I refer to as arithmetic, and the main objective of this review is to make sure that you understand the place of arithmetic in the landscape of lower division math courses. And I also want to make sure that you know how to identify the main subject or subjects of interest and tasks learned in arithmetic. And first thing I want to do is to go back and look at this landscape of lower division math courses in a traditional community college curriculum. And once again, acknowledge that pre-calculus, calculus courses form a sort of a pipeline from lower introductory courses to mathematics in general into lower division math courses and therefore into all other math courses. So the first thing that we would want to take a note of is that the main subject of interest in arithmetic is, as previously stated, are numbers and operations. And the main task, there are several tasks, but the main task is to learn how to compute. Now, if you were to only remember one thing from this review, it should be this slide. We learn numbers, we learned operations, and we learn how to compute. That is, how to apply operations on numbers. And let's start the conversation about numbers. And here I have a list of the symbols that represent different sets of numbers. So let's start with the most basic ones, natural numbers. And these are the numbers that we use for counting, such as 1, 2, 3, and so on. And remember that 0 is not considered to be a natural number. The next set of numbers is whole numbers, and it's the same numbers as natural numbers, except for 0. 0 wasn't initially considered to be a number because numbers represented quantities and 0 didn't seem to be representing any quantity. So initially it actually represented like the absence of quantity, but eventually, the saying, if it sounds like a dog and it walks like a duck, then it has to be a duck. So for that reason, 0 was introduced into the family of numbers. But by then, we already have developed certain habits, and instead of changing the set of natural numbers, we just introduce a whole new set of whole numbers. The next set is the set of integers. We label it with letter Z, and integers are the whole numbers and their negative counterparts. So this is what we refer to as integers. The next set of numbers are rational numbers, labeled with the letter Q. Q stands for the quotient. Ratio, quotient are synonymous. So here are the numbers like 1/2, 3/4, -7/15, and so on. Naturally, up until now, all the numbers, all the sets are nested in the next set below. So natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers. So I can write number 0, 1, 2, and 3 here, they are rational. Um, Now, in order for us to understand what irrational numbers are, let's talk about the next set of numbers called real numbers. And real numbers are called real because these are the numbers that can be used, or rather can be visualized on the number line. So this is what we call a, or rather the real number line. It has a positive direction. It has 0. It has a place for 1. And this defines a unit. And now this is all we need to find a place for all the numbers. So number 2 will be here. Number 3 will be here. Naturally, number -2 will be somewhere here. It's like -1, -2. Number 1/2 will be here. 3/4 will be right here, and so on. So we can visualize every number listed so far on the real number line. And then the question is, are all distances can be expressed as rational numbers? So does it mean that I can pick any point here and this distance can be expressed as a fraction of two whole or two integers? And the answer is no. So there are numbers out there that are real but not rational. And one common example is square root of 2. Square root of 2 cannot be expressed as a ratio, and therefore it's called irrational number. Now, common examples of irrational numbers are pi, e, square root of 2, and this is usually where the imagination of students runs out. But the truth is there are more irrational numbers than rational numbers. There are infinitely many rational numbers, but there are infinitely many more irrational numbers, and I can list many of them off the top of my head. How about cube root of 2? How about fourth root of 2? How about 50th root of 2? All these are irrational numbers. I can replace 2 with 3 and generate another infinitely many irrational numbers. I can replace square root operation with logarithm base 2. Log base 2 of 3 is irrational. Log base 2 of 5 is irrational, and so on and so on and so on. So there are infinitely many more irrational numbers than rational numbers. So real numbers, again, live on the real number line. However, at some point, we come to realization that there are other numbers out there, and uh, those numbers are called complex numbers. Complex numbers, they all look something like this. You have a real part and imaginary part, and to visualize complex numbers, you just add imaginary axis, and then every complex number can be visualized as a dot on this coordinate plane where we use real and imaginary axes as a setup. So 1 plus 2i will be right here, for example. So it's 1 on the real axis and 2 units on the imaginary axis. Now, let me repeat that complex numbers exist whether you like it or not, whether you believe in them or not, they do exist. And if you want me to demonstrate that, then let me know in the comments. It takes some time to convince everyone of this fact, and we don't have time in the format of this review for that. But again, like I said, if you want me to, just let me know in the comments. Now that we know that there are different types of numbers out there, so the question is, what is there to do with those numbers? So for any number, a student should be able to locate that number on the number line. A student should be able to write that number using decimal notation and round and know how to round when necessary. For extremely large and small numbers, a student should be able to use scientific notation and know how to read and interpret it. So if your calculator gives you the answer like this, you don't accidentally misinterpret it as something else. So again, I'm not going into details, but make sure you do have this particular skills. Now, when it comes to two numbers, what is that expected from you to do with two numbers? Presented with any two numbers of any two types or of the same type, you should be able to compare those two numbers. So uh, how do we compare numbers? We locate them on the number line. Whichever number is to the left, that's the smaller number. Whichever number is to the right, that's the larger number. And if they coincide on the number line, then it is the same number. And also, for any two numbers, you should be able to perform an operation. And now here I'm going to add the word binary. So when you have two numbers and if operation is performed on two numbers, it's called binary operation. So you may ask what other operations are there. And as you can imagine, this prefix bi suggests binary means two. So whatever there is two, there's got to be one or three. So trinary operations, I guess, not that common. But the other alternative that you should know, and you are familiar with such operations, they're called unary operations. Un stands for one, or uni, I guess, stands for one. So examples of binary operations will be pretty much any operation that you can think of, such as addition, subtraction, and I'm listing operations in the order they are introduced to us historically. So first we learn how to add, then we'll learn how to undo addition by subtraction, then we'll learn how to multiply. So repetitive addition is called multiplication. Then we'll learn how to undo multiplication, so we come up with division. Now repetitive multiplication is called, and you can pause here and try to remember what it's called, and then unpause when you're ready. It's called um, exponentiation. Now, again, notice the trend. We learn how to do something, then we'll learn how to undo it. Addition, subtraction, multiplication, division, exponentiation. How do we undo exponentiation? Well, there are actually two ways to undo it, a radical and a logarithm. So radical gives us the base, logarithm gives us the power. So again, if you had those thoughts that why the hell do we need logarithm? Why is it really necessary to know logarithms? The answer is yes, it is necessary. Without logarithms, the set of operations simply will not be complete. So all these operations are binary. As you can see, you need two numbers to add, you need two numbers to subtract, two numbers to multiply, two numbers to divide, two numbers to exponentiate, two numbers to take the radical, and two numbers to find a log. Now, here's the only example of unary operation that you need to know is it is called the absolute value. So here's the list of 7 operations that you should be familiar with. Remember this number 7. So the number of operations is not 300, 3000. It's not 1 or 2, it's 7. Later, we'll make a connection between the operations and functions. So um, I guess I'll give you a little heads up. The number of types of functions that we will be studying in the near future is also 7. It's not a direct correspondence between those two numbers, but those two numbers are related. So there is a relation. All right, now that you know the different types of numbers and different operations, naturally, um, what does it mean to know how to compute? That means you know how to perform each operation on each set of numbers. So this table right here kind of summarizes one's knowledge of arithmetic. If you can find all of these answers, or if you know when some of these expressions make no sense, that means you probably understand arithmetic. So let's start with natural numbers and let's do a quick check. Do you know what 2 plus 3? Should be easy. 5 minus 1, 3 times 5, 8 divided by 4, 3 to the power 4, cube root of 8, log of 16 base 2, absolute value of 3. When we're talking about whole numbers, the difference between natural numbers and whole numbers is in the presence of 0. So the only thing you have to address here is, hey, do I know how to add 0? Hey, do I know how to subtract 0? Do I know how to multiply by 0? Do I know how to divide 0 by something and something by 0? You should know that division by 0 is not allowed, so this expression makes no sense. Now, this is a good time for me to remind you that operations have something that's called domain. So operations don't work on all numbers. And I guess these words sound familiar to you, domain and range. So domain is what can go into operation. Range is what comes out of the operation. So for example, domain of division is such that we do not divide by 0. Now, on the other hand, exponentiation is okay. We can raise to the power 0 and we can raise 0 to almost any power. In this case, natural power. We can certainly raise that. Taking a cube root of 0 makes sense. Taking a 0 root of 3 doesn't make sense, and you should know that. Logarithm of 16 base 0 makes no sense. Logarithm of 0 base 2 also makes no sense. Those expressions are not well defined. So absolute value of 0, of course, is 0. Now, when it comes to integers, the only thing you have to make sure of is that you know how to handle negative numbers. So do you know how to add negative numbers? Do you know how to, I guess, subtract negative numbers? Do you know how to multiply negative numbers? Do you know how to divide negative numbers, or negative number by a positive number, or positive number by a negative number? Do you know how to raise to a negative power? And do you know how to exponentiate a negative base? Do you know that you can take a cube root of negative 8, but you cannot take a square root of negative 4? This one is not defined. What does that mean? That means negative 4 is not in the domain of the square root operation. Same here. Bases of logs cannot be negative, and we cannot take logs of negative numbers. However, absolute value of a negative number is well defined. Rational numbers. Do you know how to add fractions? Do you know how to subtract fractions? Do you know how to multiply fractions? And do you know how to divide fractions? Do you know how to raise a fraction to a whole power, or how to interpret a fractional power? Do you know whether this expression makes sense or not? And this expression actually does make sense. So there's nothing wrong with this expression, and you should be able to interpret it and actually compute it. Now, can we have a log with a fractional base? And on the other hand, can we have a log of a fraction? Both answers are yes. Can you find the absolute value of a fraction? There's nothing special about absolute value of a fraction, so that's easy. Now, before we talk about operating on irrational numbers, let's address working with real numbers. And when it comes to working with real numbers, decimal form and rounding are your best friends. If you know how to write a number in decimal form and round it, um, and then perform operation, then you pretty much set. So that means there are no special rules for adding square root of 2 and pi. How do you add it? Well, you write square root of 2 in decimal form, rounded to the nearest thousandth. Then you write pi in decimal form, rounded to the nearest thousandth. And then you add those two numbers just like you add natural numbers or rational numbers. Why is that? Because when you take irrational number and you write it in decimal form and round it, it actually becomes rational number. So your skill of writing a number in decimal form and rounding turns any irrational number into rational number, meaning if you answered yes to all of these questions, now you have to answer yes to all of these questions. So let's not really worry about working with irrational numbers. When you, at the end of the day, when you go to Home Depot to get a piece of lumber, you're never going to ask for square root of 2 plus pi 2 by 2 or feet of 2 by 2, right? You're going to sound crazy. So in practical applications, this is more important than being able to nicely write irrational number. Anyway, let's move on. Let's move on to complex numbers. And here, again, you may know it, you may not know it, but adding complex numbers is pretty straightforward. I'm not here to teach you how to do this. If you don't know, it's actually fine. It's not that important. So adding, subtracting, multiplying, and dividing complex numbers is pretty straightforward. Believe it or not, finding absolute value is also pretty straightforward because if you define absolute value as the distance to the origin, when you look at the complex number represented on this graph, where you have real and imaginary axis, distance to the origin is well defined, right? So finding the absolute value of a complex number is pretty straightforward. Now, these three computations are not trivial, and I definitely don't want to bother you with them. So this one, and this one are not trivial. But what remains true for exponentiation, if you have two numbers, or rather three numbers that satisfy this equation, then this is also going to be true. Nth root of c will be equal to b, and log of c base b is going to be equal to n. So if you can find complex numbers that satisfy this equation, then you definitely know how to find the nth root of this number and log of this number, which is pretty cool. However, as I said, these are the only three computations that you may not be 100% comfortable with. So as they are not trivial. Everything else you should be able to know and given any two numbers, find the answer. All right. Now, when it comes to more than two numbers, working with more than two numbers, then now we're getting into the computational numerical expressions conversation. And the most critical skill now is the order of operations. Can you, given a numerical expression with bunch of numbers and bunch of operations, can you figure out the right order and produce the right result? Again, I'm not here to teach you how to perform the order of operations, but I'm just going to remind you that parentheses or any other grouping symbols such as square brackets or figure brackets sometimes are also used, must be done first. Now, when you have logarithms, absolute value radicals or long division bars, you have to treat them as if there are parentheses inside, right here. And for the division bar, you have to treat it as if there are parentheses at the top and the bottom, and you always have to treat those first. Now, the idea is that when you have nested sets of parentheses or other grouping symbols, you compute the one inside first. Once you compute the numerical expression inside of the parentheses, you can replace it with the answer. So for example, here, if you have something 3 minus, and then there is a whole bunch of stuff here, and after you computed it, you ended up with answer 2, you can literally kind of wipe out that whole thing and replace it with number 2. Now you compute what's inside of this parenthesis, it's going to be 1. So now I'm going to wipe out this whole thing and replace it with 1. And finally, once you get rid of all the parentheses, once you perform all this logs, absolute value radicals, and long division bars, now we kind of rely on the pandas rule, I guess. E stands for exponents, so exponents have a higher rank in order of operations. Then we have multiplication division. Even though m goes first, it has the same ranking as division. And then we have addition subtraction. And again, even though addition comes first, it has the same rank as subtraction. So if you have bunch of addition subtractions, you perform them from left to right in the order that they appear, and the same applies to multiplication and division. Now, if you know this, you can put the end to thousands of these conversations on Facebook, because there is one correct answer to this arithmetic problem. First, we do what's in parentheses. So we have to perform this addition first. 1 plus 2 is 3. And now what do I put here between 2 and 3? What is this operation? This operation, even though there is nothing there, is called implied multiplication. At some point, we just said that instead of writing 2 times x, we're just going to write it as 2x. So sometimes we omit this symbol, and we call this implied multiplication. So we are not confused by this 2x. We understand that there is a multiplication there. So because of that, we're going to put multiplication here. And the fact that it was implied doesn't mean it has a higher ranking. It has the same ranking as division. So now we're going to perform division and multiplication from left to right in the order that they appear. So the final answer is 9. And if you go to thousands of these discussions on Facebook, you'll see that not everybody will agree with you. Now, if you are still confused after all these years by how to do a computation, then my advice is, hey, let's recognize the fact that we live in 21st century and nobody's gonna pay you for doing this type of work by hand. So there is nothing wrong with going to the internet and looking for online calculators. And the two that I would recommend, Wolfram Alpha is, you spell it Wolfram Alpha. So it's just wolframalpha.com. It's a more powerful tool than any other one that's available out there. But if you need just simple arithmetic, then Desmos has a basic calculator. So once again, I'd rather you go online and use technology to get this right instead of you struggling and suffering doing it by hand and get it wrong. Now, when it comes to using technology, again, the fact that you're allowed to use a calculator to perform computation doesn't make it any easier. You still have to possess the skill of being able to convert the mathematical expression into input for technology. So here's a screenshot from some book online that I found. Again, it's not a comprehensive list of all possible conversions, but this is what you definitely need to know, right? So if you have to choose now between learning how to do it by hand or learning how to use technology, I would rather you learn how to do computations using technology. All right. So now that we are done with this conversation about computing, what else we learned in arithmetic? And one thing that we learn in arithmetic is it's a kind of like a high level conversation. So after you learn about numbers, and then you learn about operations, and then you learn how to perform operations on numbers, then you sit there and you're like, what else is there to do? And the thing, and what you do is you just start studying the objects that you learn. So you start asking yourself, what are the properties of these numbers? What are the properties of these operations? Is there any connection between different operations? And what I'm going to show you next is the list of all simple observations, relations, and properties of operations that I can remember. So this table, for example, shows you the relation between operations that I mentioned earlier. Subtraction undoes addition, division undoes multiplication, radical and logarithm undo exponentiation, and you should know that. The next table shows you properties of addition and multiplication side by side. These properties are called commutative, and this is associative, and this is inverse property. So when you look at it, you suddenly realize that there is connection between addition and multiplication, right? So there is more to it than just multiplication is a repetitive addition. Next table shows you the rules for combining addition and multiplication, and it's called the distributive property. So we distribute multiplication over addition, and we can distribute from the left, from the right, we can distribute over multiple summands. Now, since subtraction is the undoing of addition and division is undoing of multiplication, of course there is a relation between these two as well. And this table demonstrates that relation. The distributive property can now be applied to division and subtraction, and multiplication, subtraction, and division and addition. And this table summarizes those properties. Again, the goal here is not for me to teach you all of this. So if you need more time, feel free to pause and look at it, or maybe even copy it to your notebook. But if you have any questions about any of this, just let me know in the comments. Now, these properties are not just for us to say that, oh, we know something cool. These properties actually can help us with practical tasks such as computation. So for example, associative property or commutative property together with associative property just means you can reshuffle addition and subtraction. And that means if you have to compute something like this, instead of doing 9 minus 20 first and getting into the realm of negative numbers, you can add 80 first, then subtract 20, and then add 9, which avoids negative numbers altogether and gives you the answer almost right away. Same can be said about multiplication and division. You can reshuffle the order. And for example, if you have to multiply and divide this, if you multiply 64 by 9, you get like some three-digit number. I don't even know, 570, what, 6? And then good luck dividing that by 16. So why not instead divide 64 by 16 and then multiply by 9? Much easier. So there are many benefits of writing or studying the properties of numbers and operations. Now, you have to be extra careful when performing computations that involve negative numbers and fractions. So these are the rules for adding and subtracting integers. These are the rules for multiplying and dividing integers. So you know negative times negative is positive, but negative by positive is still negative. Now, these are the rules for writing equivalent fractions and for reducing a fraction to the smallest terms. Now, these are the rules for adding and subtracting rational numbers. These are the rules for multiplying and dividing rational numbers, in case if you forgot those. These are the rules, or rather the properties of exponents, along with the definition and examples. So if you ever need to refresh your memory on the properties of exponents, here they are. Now, notice here's a property, one property, actually surprising property, because we know radicals as the undoing of exponents, but this property shows us that radicals are actually exponents, which is kind of mind-blowing. So that means when it comes to properties of radicals, they are pretty much the same as properties of exponents, and the two most important ones that worth mentioning are the ones where you have two radicals multiplied with the same indices and two radicals multiplied with the same radicand. And here are some examples. Finally, these are the properties of logarithms. And the most practical one here is the change of base formula. This pretty much tells you why isn't every calculator has a log base 3 button, log base 4 button. Well, the answer is because of the change of base formula. You don't need to have all those buttons, but every calculator has log base 10 and log base E buttons. Now, finally, these are the properties of the absolute value that you should be able to remember. Now, we cannot talk about arithmetic without mentioning the fundamental theorem of arithmetic. And here, before you can understand the fundamental theorem of arithmetic, you have to understand what a prime number is and what is a composite number. A prime number is a natural number that has only one way to factor it, that is, that number multiplied by 1. A composite number is a natural number that is not prime, meaning it can be factored into a product of two prime numbers. Note that 1 is neither prime nor composite, so we don't classify that number as any of these two, belonging to any of these two groups. And now the fundamental theorem of arithmetic says that if you look at all the numbers, then all the natural numbers, then the number, every natural number is either prime or can be broken down into the product of prime numbers. And what does that mean to us as someone who just starts learning mathematics? Well, first of all, this is kind of the beginning of the number theory, which is not even anywhere on the lower division courses map. But again, from the practical point of view, what does it mean to us? That means given any natural number, you should be able to either declare it as prime or provide the prime factorization of this number. So here's something for you to review. This is the first 100 numbers, and each number is either declared as prime or given the prime factorization. The most common mistake is, I think, 91. People forget that 91 is not a prime number, but everything else is pretty clear. If you know multiplication table, you should know which numbers are prime and which numbers are not. And when they are not, then you should know their prime factorization. Now, immediately, as a bonus, once you know how to decompose a number into prime or not, I'm sorry, into prime factorization, the following skills are something that we acquire right away. For any two given numbers, we know how to find GCF and LCM. GCF stands for the least common factor, LCM stands for the lowest common multiple. You may wonder, why the hell do I need to know this? Well, knowing GCF helps you to reduce a fraction. Knowing LCM helps you when it comes to adding and subtracting fractions. So if you know someone who struggles with fractions, who says things like, oh my God, I hate fractions, I don't know how to work with them, ask them if they know how to find GCF and LCM, because that's the prerequisite skill for that. And trust me, if once you teach them how to decompose each number and then find the LCM and GCF for any two numbers, then you can immediately pick up all the skills necessary to learn how to reduce a fraction or add and subtract any two fractions. So this pretty much concludes the review of arithmetic. And the only thing I need to mention here is I'm just going to give you like the list of vocabulary that that you should be familiar with. And once again, in arithmetic, what we learned is numbers and operations. And the main thing we learned to do with them is to compute. Now, whether you do it by hand or with technology, it really doesn't matter at this point as long as it is 100% accurate. If you can do it by hand, good. If you can't do it by hand, learn how to do it with technology of your choice. If you have any questions about any of this, if you want to get into more details um, of anything that I mentioned in this review, please let me know in the comments or reach out to me and I will make another video. That's it for now. Once again, if you have any questions, let me know.